For those that don't know, this article is clearly designed for me. How we saved 98% in cloud costs by writing our own database. I don't see how that's ever a good idea. Like, yo, dog, why not just host Postgres? Like, how is building your own database the move? We'll find out. Here we go. What is the first rule of programming? Maybe something like do not repeat yourself, or if it works, don't touch it. Or how about do not write your own database? This actually is a great first rule of programming. It should be don't write your own language, which is why we have all the languages. And 2 should be don't write your own database. Well, too late. I feel like databases are the only things growing faster than JavaScript frameworks right now. Is that fair to say? So Jonathan Blow disagrees. I think the thing is that I think Jonathan Blow disagrees, but when you write your own language, usually you start writing it after decades/decades of experience. And I think at that point, it's pretty okay to say, hey, I think I have an objectively better way to do something. I actually do agree with that statement. Jonathan Blow's a walking L take. L meaning lovely. Perfect. He has a lot of good takes. I think he has a lot of bad takes, especially his ones about open source. I'm like half in, half out on those ones. I don't really know where I land. You know, they're pretty good. Anyways, that's a good one. Databases are a nightmare to write, from atomicity, consistency, isolation, and durability, requirements to sharding, to fault recovery, to administration. Everything is hard beyond belief. If you haven't seen the video, I have a video on my channel about Tiger Beetle. The presentation for it starts off a little slow, but man, it gets so good, and then it turns into a video game they wrote in Zig to represent what's happening in the Tiger Beetle database. It is wild. It is wild. Like, writing a good database and how they go about with testing and everything is just incredible. Fortunately, there are amazing databases out there that have been polished over decades and don't cost a cent. So why on earth would we be foolish enough to write one from scratch? Well, here's the thing. This is actually how every bad meeting started for me. All right, we are running a cloud platform that tracks tens of thousands of people and vehicles simultaneously. FBI, NSA. What's the name of your company? Oh, it just happens to be NSA. Okay, cool. What does NSA stand for? Every location updated is stored and can be retrieved via a history API. The amount of simultaneous connected vehicles and the frequency of their location updates varies widely over time, but having around 13,000, they're from the EU. This isn't America, people. This ain't America. This is not America. That's not us. That's you guys. That's you. That's on your side of the pond. That's not my problem. This must be Macron's creation, okay? Simultaneous connections, each sending around one update a second. Wow, that's a decent amount of updates come flying in via just persistent connections, right? A squash mess! Our customers use this data in very different ways. Some use cases are very coarse, e.g. when a car rental company wants to show an outline of the route a customer took that day. This sort of requirement could be handled with 30 to 100 location points for a 1-hour trip, and allows us to heavily aggregate and compress the location data before storing it. Oh, yeah, that makes sense. Okay, I'm starting to understand what they're doing, what they're tracking, and kind of what they're reporting. But there are many other use cases where that's not the option. Delivery companies that want to be able to replay the exact seconds leading up to an accident. Mines that with very precise on-site location trackers that want to generate reports of which worker stepped into which restricted zone by as little as half a meter. What's the accuracy of GPS? I thought it was like 6 meters. Has that changed? 3 meters these days? Okay, when I was doing stuff in college and at post-college, it was 6. 6 meters is super accurate. RTK can get down to 10 centimeters. What the hell's RTK? So I don't know RTK. What's RTK? RTK makes it even better. What is that? I've never heard of RTK. You wouldn't use GPS for this. Okay. RTK. So, yep, this is beyond my abilities. I haven't been in the hardware biz for over a decade. Real-time kinematics. Oh, interesting. So, given that we don't know upfront what level of granularity each customer will need, we store every single location update. Okay, this makes sense. In other words, you have like a table, then you have aggregate tables or some sort of post-processing tables. I wonder why that doesn't work. At 13,000 vehicles, that's 3.5 billion updates per month, and that will only grow from here. So far, we've been using AWS Aurora with the PostGIS extension for geospatial data storage, but Aurora costs us upwards of $10,000 a month already just for the database alone, and that will only become more expensive in the future. Okay. But it's not just about Aurora pricing. While Aurora holds up quite well under load, many of our customers are using our on-premise version. And there, they have to run their own database clusters, which are easily overwhelmed by this volume of updates. Okay. Okay, this makes sense. I'm not gonna lie, these costs are pretty tame. These costs are pretty tame. As far as like a tech company goes, I mean, they actually have customers here. They have literal captures, right? So we burnt about 28,000 on our Aurora migration this week. Yeah, I figure a lot of people spend a lot more. Why aren't we just, let's see, this is such an interesting choice to make at this low. I mean, I guess if you're trying to future-proof yourself, knowing it's going to go from 10,000 to say 100,000 over the course of the next 2 years, maybe it makes more sense to start pre-preparing for this stuff. But I'm just curious if maybe just not having a managed database, but just hosting your own database would have been a better choice. Right? Maybe you could have reduced it without so much engineering talent and time and all the things that go with, you know what I mean? Unfortunately, there is no such thing. If there is, and we somehow overlooked it in our research, please let me know. Many databases from Mongo and H2 to Redis support Redis. Boo! Can we get boo? Boo Redis! Boo! So for those that don't know, Redis is not Redis the original open source, as we learned like 2 days ago. Redis is actually a company that usurped Redis the open source. What appears to be kind of pressured the guy to sell the IP. The guy didn't really want to be a maintainer. He wanted to go off and write hardware or something. So he was like, all right, whatever. And he left. And then Redis, the company was called something else. It was called like Redis Online or something like that. Then became Redis. And then changed the labs, Redis Labs. They were from Redis Labs to Redis, and then changed the license and all that. Yeah, Garantia, or however it was. And so anyways, there's a good video on that. But they are exclusively extensions that sit on top of existing DBs. PostGIS, built on top of PostSQL, is probably the most famous one. There are others like GeoMesa that offer great geospatial spatial querying capabilities on top of other storage engines. Unfortunately, that's not what we need. Here's our requirement profile looks like. Extremely high write performance. We want to be able to handle up to 30,000 location updates per second per node. They can be buffered before writing, leading to a much lower of IOPS. So the thing is, I don't know much about geospatial databases. I know they exist, and obviously there's some level of already solved nature to this in the industry. And I don't want to like just shit on something being recreated, because obviously Tiger Beetle got created, and it turned out to be incredible for Tiger Beetle, right? You wouldn't want to use Cassandra. You'd want to use Scila, right? Scila is the way to go for any of those things. Scila is just Cassandra, but written in a fast language, not JVM. But 30,000 updates per second doesn't sound wild, right? This doesn't sound like for larger companies. I mean, obviously for smaller companies, right? For anyone with 20 or less engineers, this is probably really, this would be a much harder thing to solve, because now you have to actually have a dedicated staff to trying to solve these things, maybe 2 dedicated staff trying to solve these things, right? Which could be a real big hit to your bottom line. But it doesn't seem like this isn't already there. Well, you got management, you got on-call, you got stuff, you got things you got to think about, right? If you're to try to go from a managed service to you managing a service, I mean, there's uptime requirements, being, setting up all the infrastructure and all that. It's per node. Yeah, per node. Okay, so per node, per database. I'm still not sure. I mean, hey, I could be wrong. Remember, Tiger Beetle came from necessity that I probably would not have understood, and probably would have been like, hey, that's kind of silly to write your own database. And then Tiger Beetle is absolutely amazing. 30,000 privacy violations a second. It doesn't look like privacy violations. I actually don't think this is privacy violations at all, because it's talking about tracking workers in sensitive areas and rental car stuff. When you do rental cars, of course, you're getting tracked on that. That makes perfect sense that the rental cars want to be able to ensure that you did what you did, right? You guys made a contractual agreement that you would drive their car like this. They would get this out of it, right? Right. Keep saying per node, per node. I know, I see per node. Okay, so per node, that maybe that makes more sense. 30,000, write operations per second. Unlimited parallelism. Multiple nodes need to be able to write data simultaneously with no upper limit. Small size on disk. Given the volume of data, we need to make sure that it takes little space on the disk as possible. To be fair, when you have your own data format, and this is all you need to store, and you know that this isn't changing much, it technically is most efficient to write your own bespoke storage for this specific operation. But man, you'd have to really convince me that this is a good idea, because it is. I mean, you really just hired 5 engineers to do this, right? You can do, yeah. Famous last words. I know. I'm just saying, this is crazy. This is very interesting. Moderate performance from reads from disk. Our server is built around an in-memory architecture. Queries and filters for real-time streams run against data in memory, and as a result are very fast. Reads from disk only happen when a new server comes online. When a client uses the history API, or soon when a user app rewinds time on our digital twine interface, these disk reads need to be fast enough for good user experiences, but they are comparatively infrequent and low in volume. Okay, so optimizing for writes. Okay, low consistency guarantees. We are okay with losing some data. We buffer about 1 second worth of updates. Our digital twin interface. Okay, stop making fun of it. I said twine, okay? Whatever. In the rare instance where a server goes down and another takes over, we are okay with losing 1 second of location updates in the current buffer. Okay, they even have fault tolerance. I am curious why the other solutions didn't work out for this. What sort of data do we need to store? The main type of entity that we need to persist is an object. Basically, any vehicle, person, sensor, or machine. Objects have an ID, label, location, and arbitrary key value data. For fuel levels or current rider ID, locations consist of longitude, latitude, accuracy, speed, heading, altitude, and altitude accuracy, though each update can only change a subset of these fields. In addition, we also need to store areas, tasks, something an object has to do, and instructions, tiny bits of spatial logic the HiveKit server executes based on the incoming data. Altitude? Yeah, like how high up they are. What we built. We've created a purpose-built in-process storage engine that's part of the same executable as our core server. It writes a minimal delta-based binary format. A single entry looks like this. Okay, entry length, nice. Okay, so this is starting to look like a TCP protocol. It almost looks like something you could also just UDP over to another server. Kind of interesting that, because given the fact that they don't need consistency, they could technically UDP it onto many servers to be stored, right? It's interesting, right? Flags, ID, type, index, timestamp. Okay, latitude, longitude, byte length, data, byte length, label. Okay, interesting. Sounds like overkill. I'm sure we're missing many pieces of information here that make this make sense. But let's see. They might lose data. They said they're okay with losing data, which I think is probably fine, right? UDP reliability doesn't work great in lossy fabrics. Yeah, that's fair. Each block represents a byte. The 2 bytes labeled flags are the list of yes-no switches that specify has altitude and has longitude, has data, telling our parser what to look for in the remaining bytes of the entry. We store the full state of an object every 200 writes. Between these, we only store deltas. That means that the single location update complete with time and ID, latitude and longitude takes only 34 bytes. This means we can cram about 30 million location updates in a gigabyte of space. Okay, very interesting. I wonder how they decide when to do like iframes, right? So iframes, if you don't know what an iframe is the frame of video that's coming down that has the full position. And then you do P frames, which P frames are the differentials, right? And there's also B frames, which is like backward, forward differentials, but we're not going to talk about that. And so like how often do you do diffs versus how often do you do full data point storage? Pretty interesting stuff. It's kind of like they've created their own video encoding on top of spatial data. Right? Every 200? Oh, every 200? Oh, yeah. You know, when you say it out loud like that, it makes perfect sense. Pre-read. We also maintain a separate index file that translates the static string ID for each entry and its type. It's into a unique 4-byte identifier. Since we know that that this fixed size identifier is always byte index 6 through 9 of each entry, retrieving the history for a specific object is extremely fast. Interesting. It's a B tree probably somewhere. The result, 98% reduction in cloud cost and faster everything. The storage engine is a part of our server binary, so the cost of running it hasn't changed. What has changed, though, is that we replaced our $10,000 a month Aurora instance with a $200 a month Elastic Block storage volume. We are using provisioned IOPS SSD IO2 with 3,000 IOPS and are batching updates to 1 write per second per node and realm. I am sure a lot of people are thinking something very similar that I am, which is the engineering cost has to be significantly more than $10,000 a month for this to actually be written, tested, validated, all that kind of stuff. Improvements. You now have a binary storage, which means you need versioning. One thing I can see right away that they goofed up right here, if you look at this, the header does not have a version field. Like, one of the biggest mistakes people make when they do novice binary encoding is not considering a version field. This is like probably the single most important thing to do. And the thing is 1 byte is probably enough for your version field, but 2 bytes if you want to be super safe. Like, real talk, like, how are they going to know, right? How are they going to know when they need to change the format, right? So for me, the version is a dead giveaway that this is maybe a bit more novice of a binary encoding attempt. So each block represents a byte. The 2 byte labels, labeled flags, are a list of yes/no switches. Okay, so there you go. Like, has altitude, has longitude, has data. So again, so this is this is why you would desperately want a version field right here. Because again, imagine if you needed more than 16 flags all of a sudden. You might find yourself needing to change your header format. Very, very important to do. Let's see. We already talked about that. All right, as a result. So, cool, they've saved some money. I'm very skeptical. I mean, obviously, the layman in me says, you saved $10,000 a month, but you might have cost yourself $50,000 a month of engineering effort, which theoretically would get paid back. But I think the thing that they alluded to earlier makes this make a lot more sense, which was their on-premise part. There you go, on-premise version. So they have an on-premise version. So maybe my guess is that this is what it's attempting to solve. Also, is they have the on-prem kind of like thing that's kind of coming down on them that's actually causing a lot of difficulty. Why we added a version field to our DB. I really hope they do add a version field, because honestly, it is, dude, the boy just bet that he could get it right first try. And trust me, every single binary protocol I've ever written. In fact, if you go to Vim with me, and we go in here and we look at what do we get? Do I have anything that's called encoding? TCP. The first thing I did when building our own TCP packets was put a version in it. Version is the first part of our encoding, right? This is step requirement numero uno, right? Because you just have to. Whenever you build anything that involves just raw dog and TCP or any of these type of stuff, oh man, you got to be ready for you to screw up. You screwed up. That's all there is to it. You didn't foresee something. It has to be step one. EBS has an automated backups and recovery built in and high uptime guarantees, so we don't feel that we've missed out on any reliability guarantees that Aurora offered. We currently produce about 100 gigabytes of data per month, but since our customers rarely query entries older than 10 days, we've started moving everything above 30 gigabytes to AWS Glacier. By the way, Glacier, I thought was one of the coolest characters in Killer Instinct, for those that are just wondering, thus reducing our EBS costs. But it's not just costs. Writing to a local EBS via the file system is a lot quicker and has lower overhead than writing to Aurora. Queries have gotten a lot faster too. It's hard to qualify or quantify since the queries aren't exactly analogous. But for instance, recreating a particular point in time in a realm's history went from around 2 seconds to 13 milliseconds. Super cool. Again, I feel like I've said this more than once, which is creating your own storage for your specific needs will always be, and if you're good at it, of course, assuming you have no skill issues, will always be the single best way to store your data because it's bespoke to you. But it is also absolutely the hardest, most challenging, probably you shouldn't do it move. Throwing that out there, okay? Just saying, you probably shouldn't do that. But this is very, very impressive because this is several orders of magnitude. It's a nightmare of skill issues. It is a nightmare to do, and you should effectively never do it. Unless if you're Tiger Beetle, or apparently these guys. Of course, that's an unfair comparison. After all, Postgres in general, Postgres is a general purpose database with an expressive query language, and what we've built is just a cursor streaming a binary file feed with a very limited set of functionality. But then again, it's the exact functionality we need, and we didn't lose any features. If they have started archiving everything after 30 gigabytes, then I probably would have started by keeping everything in RAM and buffering 3x machines. Yeah, that's kind of interesting. And then you could do that whole like UDP talk cycle, right? Because once you hit the backbone, you're probably going to get very low packet loss. and you could just like have some sort of crazy round robin, everything stays up, have a node that can just kind of handle it at all times, and then hit it with the cold storage, the Glacier, afterwards. We do not have skill issues, the writer. Very, very interesting. Yeah, this feels like a little overkill, but still, I mean, it's super cool though. Let's see, you can learn more about HiveKit's API and features. Oh, cool. Okay, so then did they open source this as well? Location infrastructure for the internet. HiveKit provides, okay, when you say it this way, it does make you feel like this is actually the NSA again, okay? I know you tried to trick me, NSA, with your European unit writing with periods instead of commas, but you're not faking me this time. I know what's happening here. You're trying to bamboozle me. Absolutely. Moral of the story, just use ETS. Constant time in-memory store built in Erlang. Dude, Shirai never misses an opportunity. Never miss an opportunity. Every good story can be made better by mentioning Erlang. It's just a fact of life. That was really cool, though. I actually really genuinely liked this. I really genuinely liked this article. Again, just please, if somehow this gets out to you, creators of said product, I didn't even realize that we were reading like an actual product with pricing and all this. I didn't realize this till now. Is this an ad? Did I just get an ad? Can you pay me money? You want to pay me money for this? No. Anyways. Please, for the love of all things good and holy, put a version field in here. You will never be sad that you put it, and you will always be sad that you didn't have it. Hashtag ad. Did we just add ourselves? Did I just give you guys some aids? I think I might have. Slash NSA. NSA, if you could pay me. I don't know how much money I'd need from the NSA to sell out my soul for being able to track people, but I mean, I assume we're getting the bag, NSA. All right, hey, that was awesome. Now let's talk about being unemployed. The name. Is the database engine. Is the binary engine.